Cool. Hi, my coding was done on software Greenfoot using the Java programming language, and Greenfoot was just the perfect for my simulation because it displayed the coding on an interactable, visual interface, and this was really key in completing my goal of helping users visually understand black hole interactions on a higher level. And so the screen appearance that you see is initialized by the world class, which sets the size and location of everything, all of the different actors, and sets completing the criteria for success. Number one, the interface of the simulation is a clear representation of a cosmic background. And this is also interactable because every time I hit reset here, and the X and Y intercepts for 5 black holes are randomly generated, and this is used to make the functionality of the program just more interesting for the user by changing every time. And so also, here, I'll just get it like that. And then also to make this program and simulation more interactable, I allowed the users to choose an end location for the spaceship and to launch it there. So if you hold down the M key, which you can see in the heading down here, it says the direction. So if I'm holding down the M key and I'm clicking on a location, I have to press run first. There we go. The black hole will move there, and so I can pretty easily move it around everywhere. And when it hits the end screen, it kind of bounces back. And that's completing the criteria for success number 8, which is just having an end location and pretty flexible movements. And I utilize Greenfoot's very helpful. It was mouse info class to gather the data from the user's mouse. And so when I hold down the key and when I click on a location, it knows what's the variables I'm sending the code. And if the user for some reason wants to remove all of the black holes and they're just annoyed with those locations, they can hold down R and just click anywhere on the screen. And this is completing the criteria for success. User can easily remove the black holes from the interface. And now that all the black holes are removed, the user can choose to add them back where they desire if they want to, just by holding down the A key, which I am doing right now, and then clicking anywhere on the screen where they desire the black hole. So I'll just do right there. And yeah. And so that's completing the criteria for success. User can add multiple black holes to the interface. I could add just a bunch of them anywhere. It's just kind of fun. And they also completing the criteria for success that user can determine the X and Y intercepts of where they want to go. And now here comes the key part of the program. So each Greenfoot actor, such as the sun, black hole, etc., are running through a loop of methods that are initialized by a main act method. And so this is really essential. When the spaceship moves, it's always running through a method called sucked up, which checks to see if the spaceship's location is near a black hole. And to make this possible, I used Booleans, which allowed me to set a clear true or false state to the spacecraft. So it's either a safe distance away, as it is now, or it's too close. And so I'll just demonstrate this. If the spacecraft is moving closer and closer to a black hole, there you go. It says that your spacecraft has been sucked into a black hole. And this is completing the final criteria for success. If the spacecraft gets too close to a black hole, the simulation ends. And this also applies to the sun. If the spacecraft is too close to the sun, the simulation will end. And what I would add if I had more time, I would want the user to determine the size of the black hole, because I think that could make things more interesting. And also, additionally, I would want to include more about the unique effects of black holes on objects rather than just sucking them in, because I think that's a pretty elementary level. And I know that if I had a further ability, I would want to, for example, just show that there's an impact on an astronaut's time when they're going near a black hole, and time dilation would be a really good thing to output and interesting variable to showcase. And further information and specifics of this program can be found in Criteria C. So thank you.